dou by dou f x it was also there. And next is we want to find this part, like the b cross del cross a. This part of x component that we have to find and want to substitute here. So what is del cross a? Del cross a is dou by dou x, dou by dou y, dou by dou z, and how we will be taking this. Then I get into dou by dou y of
az
minus
dou by dou z of ay.
dou by dou z of ay. This is I component
Minus
minus then get into
dou by dou x of az.
dou by dou x of az
Minus dou by dou z of x.
And we want to find
Plus
k cap into
dou by dou x of
dou by dou x of
ay
minus
minus
dou by dou y of x. Okay. And now what we want to find is b plus del cross a. B plus del cross a is what we want to find. And here b will be dx, dy, dz. And del cross a is what we found here. So we want to write this here. What is the I component?
dou az by dou y
Dou az by dou y
minus
minus
dou ay by dou z.
dou
ay
ay
by dou z.
Then for ij component, dou az by dou x minus dou ax by dou z. And for k,
dou ay by dou x.
dou ay by
dou x minus
but here it is dou az by dou y minus dou. And here we are making this as plus. So here there will be a minus. Okay. So and here plus. Got right? Because here this I component, j component, k component, here is I j k. So we want to take not minus j plus j. So here we are taking the minus inside. So minus dou az by dou x plus dou x by dou z. Okay. Okay. And then dou ay by dou ax minus
dou x.
dou ax by dou y. Okay. Dou az by dou x plus dou ax by dou z. And then what we are doing is e cross del cross a. This is e cross del cross a of x component. So dy into what we are taking only x, like I part only we are taking because this x component. So dy into the ax by dy into dou ay by dou x minus dou ax by dou y minus dz into minus dou az by dou x plus dou ax by dou z. Got right? So in the next part what we are doing is we take this dy inside. Dy into dou ay by dou x dy minus dy into dou ay by dou y and then multiply this we will get dz into dou az by dou x minus dz into dou x by dou z. Okay. So in the next step we take these plus terms together and minus terms together. And then we are adding and subtracting bx into dou x by dou z. Dou x by dou ax by adding and subtracting dou x by dou x on right side. Like v dot a. What is the by dou x of v dot a? V is v x I plus v y j plus v z theta, and a is a x I plus a y j plus a z theta. So v dot a will be v x I plus v y j plus v z a z. So that is what we written here. That is dou by dou x into v dot x equal to dou by dou x into v x I plus v y j plus v z. Okay. So in the next term, what we are doing is taking this inside. So Vx into dou x by dou z, dou ay by dou z, dou x, and dou az by dou x. So we got dou by dou x of v cross v dot a. V dot a, this is the equation. And now here ax is equal to x of x by z and t. So function. And so from here, what we are doing is d by dx, d by dt of x. We are doing this to convert this into another form and making this to find the first equation we already written. That we want to substitute and make it smaller. For that, we are doing this much things. So dx by dt is equal to dou x by dou x into dx by dt, and dou ay by dou y into dy by dt plus dou az by dou z into dz by dt plus dou ax by dou t into dt. This is the derivative of ax by dx by dt. Derivative of ax with respect to time. Okay, so now what we are doing is dx by dt minus this term, dou x by dou t. So what we get is by this will become 1, and when we are taking this into this side, we will get dou x by dou x, dou x by dou x into dx by dt is dx. This term will become dx, and this term vy, and this term dz. This is this is dz, this is dy. So in that way we are substituting here, giving it as an equation, and then using 9 and 10 in our choice of equation A. This is equation A. So what we are doing is, what is the equation 9? This is equation 9. So here this is equal to this. So we are giving dou by dou x of then v dot a. Dou by dou x of v dot a. Instead of this, what we are giving this dou by dou x of v dot a. Understood? And the next part, in this equation, you can see okay, in this equation, this part, vx into dou x by dou x plus dou by dy into dou ay by this term we are replacing by this. For that only we did this thing. Okay, so we got this in a different form, dx by dt minus dou x by dou t. That is the v dot velocity of x. Okay, so next is we are taking this outside. So minus dA by dt plus dou a by dou x by dou t. Okay, x term will be like that's fine because we already put here x. And using that in equation 7. What is equation 7? Equation 7 we already wrote the equation of force. So there we are substituting P dot, as I have already mentioned, we want to find E cross del cross A. In that we got this E cross del cross A in short term, as a short term. That is here as equal to minus dou by dou x. This is already we wrote it as minus del phi. So that is minus dou by dou x of phi minus dou ax by dou t plus this term is substituted here. From this, and this term will have go because this is minus and this is plus. So minus dou by dou x of phi minus del dot a, sorry, phi minus d dot a minus dx by dt. Okay, so this is the another form of fx. Into minus dou by dou x of phi minus d dot a minus dx by dt. This is you find the Vx. This is same as this. Right? Dou by dou x minus dou by dou x. This is actually u. Okay? Into d by dt of dou dx. U. So this is the term u. Okay. So from that we got what is u. So here we already find that u. From here we got what is u. U is equal to q into pi minus v dot a is called the velocity dependent differential potential. So in that Lagrange equation m is equal to d minus v, we will be substituting this u instead of v. Okay, for that only we found that u and these all the steps was to find this differential velocity potential. Velocity dependent differential potential. So next, L is equal to T minus V, that is Q, minus Q into 5 minus V dot A. So this is the required Lagrangian of the charge particle in an electromagnetic field. Okay. So where K is equal to half of V square, where V is equal to Vx square plus Vy square plus Vz square, and L is equal to half M into Vx square plus Vy square plus Vz square, that is E, and then minus Q5 plus Q into E for the vector V is Vx square plus Vy square plus Vz square, and A is X square plus Ay square plus Az square. And then what we do is we wrote this T like that, and then Vx remains Vx, Vy plus Vz. That also we wrote, and then we make this as a summation term. That is half m into summation k. That k is equal to x times l. Okay, k square minus q5 plus summation q. This is q. And q is here also. Dk again, the k is equal to x square. So this is the part Lagrangian. And here, the next part we want to find, as I already mentioned, after finding Lagrangian, then we will find Lagrangian momentum. So this step you can take as maybe already wrote equation 12, 30, 40 or something. So from here we are taking this as 1. So this is another part from Lagrangian. We will be finding Hamiltonian, and from Hamiltonian we will find the Hamilton equation. Okay. So yeah, Lagrangian momentum. Here Qk. Then the coordinate is Bk. Okay, Qk is Bk, and Pk is equal to L by instead of Qk, it will be writing Ck. And how we get that Qk?
UK
Qk
dot.
is equal to d by dt of Qk, that is equal to Pk. Okay, that's right. So we find out the Lagrangian here, and in that D and B as I already mentioned. And what is Q here? Q is the charge on the particle. Q is the charge on the particle, and phi is the magnetic scalar potential. And B and A represent the velocity of the particle, and A is magnetic vector potential. So phi is scalar potential. This is vector potential. This is velocity, and kinetic energy Q. Okay. So from there we already find the generalized momentum, and next we want to find Hamiltonian. So Pk is equal to finding p the earlier question we find p theta, but theta not. That one is the for p we want to find. In that way we are finding here p. So for p we give double star equation and this is equation star. And h is equal to summation of k pk pk dot minus l. Instead of that pk, what we want to give h is equal to pk. This is pk and pk 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 dot okay pk pk dot means h is equal to so we got x is equal to qk pk qk dot minus l. L is here, that term is substituted. And here pk qk this pk term we are taking inside. So m pk square plus q summation k ak pk plus sorry minus half m pk square. This minus coming inside plus q by minus. Okay, this way we are finding Hamiton. So here x is equal to and from here q in this summation of k ak vk and the minus q in this summation of k ak vk. This we can cancel and what we will get is h is equal to k m vk square minus half mvk square plus q square. That is what we are getting from here. And from there we can take 1 and minus separate outside. So we will take like this. And using equation double star in 5. In 5, what we will get? This is pk. For pk we are substituting here. So we will get pk by m minus q by q ak by m the whole square plus q by so h is equal to half k m by here we are taking this m square outside. So pk minus q ak the whole square plus q by h is equal to half 1 by 12 into k pk minus q ak the whole square plus q by. This is the Hamiton name for this charge particle in an electromagnetic field. And the next step what we are doing is this summation term we are removing and we will get 1 by 12 into p minus qa whole square plus q square. Okay. So next we want to find the Hamiton's equation. So Hamiton equation is qk dot is equal to dash by dot pk and pk dot is equal to minus dash by dot qk. And here vk is equal to dash by dot pk. Okay. So this is the Hamiton equation, and from here we have to find pk. Pk is equal to minus the by dot pk. So pk dash by dot pk and h we already know that we substituted. This is h that we substituted, and from here if we are taking the derivative with respect to pk, this will be 2 into this term and in that will be 2. And then vk is equal to 1 by m into. This one will cancel 1 by m into pk minus qak. Okay. So we will get pk as like this 1 by m into p minus qak. So this is the one Hamiton equation. So the next is we want to find pk in the same way. So pk dot is equal to pk dot is equal pk dot means pk dot is equal to dash by dot pk. And from here we are differentiating this with respect to qk. What we will get is 1 by 2 into pk minus qak minus minus v. Kinetic energy v we already know half mv by x dot square, and potential energy also we know of a spring. That is k constant. And from here px is equal to del by del x dot, and we will get here mx dot, and also from here we will get px square by 12, and h is equal to e plus p. This is p, and this is p. D is equal to, here substituting instead of mx dot, here substituting mx the whole square. So p square by 12 plus half k x square. And the next step we want to find the equations of motion for harmonic oscillator. So x dot is equal to the x by the px. So px by m. Here we will be taking derivative by taking 2px by 12. So px by m, or px equal to mx dot. And the second step, minus px dot is equal to dou x by dou x, or px dot is equal to minus dou x by dou x. From that we will get as kx. So as by comparing as we usually did, mx double dot plus kx is equal to 0. This is the equation of motion for harmonic oscillator. Okay, is there any doubt? No. So next is Cartesian. Like two dimension. Two dimension means it is same like one dimension, but instead of x dot we are taking not instead of since it is two dimension, x dot and y dot also will be there. So in the same way, what we did in one dimension, we can do two dimension and find the equation of motion and Hamilton and equation of motion. Okay, that's all about this three. So here we are taking the L by the R bar, that is equal to M R bar. So in polar the difference is that instead of x dot square plus y dot square, we are getting R dot square plus R dot square theta dot square. This is theta. So polar part we already